Cross product. From Wikipedia, the free encyclopedia. This article is about the cross product of two vectors in three-dimensional Euclidean space. Prepare for mild cognitive dissonance of Microsoft Word reading the symbols incorrectly in the following statement. The cross product or vector product, occasionally directed area product, to emphasize its geometric significance, is a binary operation on two vectors in a three-dimensional oriented Euclidean vector space, named here cap E, and is denoted by the symbol which looks like times, which looks like an X, but is supposed to sound phonetically like the word cross which it is supposed to represent. Prepare for mild cognitive dissonance of Microsoft Word reading the symbols incorrectly in the following statement. Given two linearly independent vectors A and B, the cross product which looks like and is denoted by A times B, which is instead supposed to sound phonetically like A cross B, is a vector that is perpendicular to both A and B, and thus normal to the plane containing them. It has many applications in mathematics, physics, engineering, and computer programming. It should not be confused with the dot product, projection product. The magnitude of the cross product equals the area of a parallelogram with the vectors for sides. In particular, the magnitude of the product of two perpendicular vectors is the product of their lengths. The units of the cross product are the product of the units of each vector. If two vectors are parallel or are antiparallel, that is, they are linearly dependent, or if either one has zero length, then their cross product is zero. Prepare for mild cognitive dissonance of Microsoft Word reading the symbols incorrectly in the following statement. The cross product is anti-commutative, that is looks like and is denoted by A times B equals minus B times A, which is how it is written but is phonetically sounded as A cross B equals negative B cross A, and is distributive over addition, that is looks like and is denoted by A times B plus C equals A times B plus A times C, which is how it is written but is phonetically sounded as A cross open parenthesis B plus C close parenthesis equals A cross B plus A cross C. The space cap E together with the cross product is an algebra over the real numbers, which is neither commutative nor associative, but is a Lie algebra with the cross product being the Lie bracket. Like the dot product, it depends on the metric of the space under consideration, but unlike the dot product, it also depends on a choice of an orientation of the space. This is why the space must be oriented. The cross product is invariant under a rotation of the basis but is changed into its opposite by an odd permutation of the basis vectors. Therefore, the cross product is a pseudovector. In connection with the cross product, the exterior product of vectors can be used in arbitrary dimensions, with a bivector or two-form result, and is independent of the orientation of the space. The product can be generalized in various ways, using the orientation and metric structure just as for the traditional three-dimensional cross product. One can, in n dimensions, take the product of n-1 vectors to produce a vector perpendicular to all of them. But if the product is limited to non-trivial binary products with vector results, it exists only in 3 and 7 dimensions. The cross product in 7 dimensions has undesirable properties, e.g. it fails to satisfy the Jacobi identity, so it is not used in mathematical physics to represent quantities such as multi-dimensional spacetime. See section generalizations below for other dimensions. Definition. Prepare for mild cognitive dissonance of Microsoft Word reading the symbols incorrectly in the following statement. The cross product of two vectors A and B is defined only in three-dimensional space which looks like and is denoted by A times B, which is how it is written but instead phonetically sounds as A cross B. In physics and applied mathematics, the wedge notation A and B is often used, in conjunction with the name vector product, although in pure mathematics such notation is usually reserved for just the exterior product, an abstraction of the vector product to n dimensions. Prepare for mild cognitive dissonance of Microsoft Word reading the symbols incorrectly in the following statement. the cross product which looks like and is denoted by a times b, which is how it is written but instead phonetically sounds as a, cross, b, is defined as a vector c that is perpendicular, orthogonal, to both a and b, with a direction given by the right-hand rule and a magnitude equal to the area of the parallelogram that the vectors span. The following quotation is beyond my ability to repair phonetically, so I will just delete the sound and the text and symbols will remain. The cross product is defined by the formula. Where theta is the angle between A and B in the plane containing them, hence, it is between 0 degrees and 180 degrees. Are the magnitudes of vectors A and B. N is a unit vector perpendicular to the plane containing A and B, with direction such that the ordered set, A, B, N, is positively oriented. If the vectors A and B are parallel, that is, the angle theta between them is either 0 degrees or 180 degrees, by the above formula, the cross product of A and B is the zero vector 0. Direction. Prepare for mild cognitive dissonance of Microsoft Word reading the symbols incorrectly in the following statement. The cross product which looks like and is denoted by a times b, which is how it is written but instead phonetically sounds as a, cross, b, vertical, in purple, changes as the angle between the vectors a, blue, and b, red, changes. The cross product is always orthogonal to both vectors, and has magnitude 0 when the vectors are parallel and maximum magnitude AB when they are orthogonal. The direction of the vector n depends on the chosen orientation of the space. Conventionally, it is given by the right-hand rule, where one simply points the forefinger of the right hand in the direction of A and the middle finger in the direction of B. Then, the vector n is coming out of the thumb, see the adjacent picture. Prepare for mild cognitive dissonance of Microsoft Word reading the symbols incorrectly in the following statement. Using this rule implies that the cross product is anti-commutative, that is, which looks like and is denoted by b times a equals minus a times b, but is sounded phonetically as b cross a equals negative open parenthesis a cross b closed parenthesis. By pointing the forefinger toward b first, and then pointing the middle finger toward a, the thumb will be forced in the opposite direction, reversing the sign of the product vector. Because the thumb is opposable, I don't think that the thumb will be forced in any direction, according to the Messiah. As the cross product operator depends on the orientation of the space, in general the cross product of two vectors is not a true vector, but a pseudo-vector. https://en.wikipedia.org/wiki/cross_product